Assalamualaikum and hello everyone. So in this video, I'm going to help you with your homework, which is free fall motion. Okay, when you get a question about free fall, search for the keyword. Okay, and then keyword that referring to free fall motion is when it is said that the object thrown upward or downward, vertically, object release or drop. So for the free falling motion, we can modify the basic equation that we have seen in linear motion to suit the condition or the situation, where we basically change A to negative G. Okay, number one, a book is dropped 150 meters from the ground. Determine the time taken for the book reaches the ground. Okay, so as I mentioned earlier, that you should draw a diagram, okay, to help you to label and then imagine the situation. Okay, so here, the height of the books from the ground is 150 meters. Determine the time taken. So from here, we know that S is equals to negative 150 meters. Okay, I know that many of you have forgotten the sign negative. Okay, now the books is going down, it's going lower than the reference level. Okay, so our S is negative. Then we know that G is equal to 9.81 meter per second squared. The keyword is that the book is drop, dijatuhkan. So initially the velocity is equals to 0. So U is equals to 0. Now we need to find T. Okay, so having listed all the parameters, semua parameter kita dah keluarkan. Jadi formula mana yang the most suitable to find time? Yes, this one over here. So make sure S is with negative sign and then 9.1 is also with negative sign if you haven't changed the sign over here. Okay, make sure negative tu letak sekali saja. Either awak change the equation negatif kat situ ataupun kalau awak kekalkan dengan positif, A ni kita kena masuk negative 9.1. And then the velocity of the book when it reaches the ground. Okay, sebelum dia touching the ground lah. Okay, so V we need to find, U we already know, G dengan T pun kita dah tahu. T is the time taken daripada atas straight ke bawah. Okay, so we get the V is negative 54.25 meter per second. Negative because the motion is going downwards. Okay, number two, a man jumped down vertically from the roof of a building with initial velocity of 10 meter per second. The height of the building is 72 meter. Calculate the time taken for him to reach the ground. Okay, so ada seorang lelaki, dia terjun daripada bumbung bangunan secara vertikal. Dan dia ada initial velocity iaitu 10 meter per second. Kalau yang nombor 1 tadi, buku tu dia di-drop kan. Jadi U dia adalah kosong. Tapi sekarang ni soalan bagi tahu, the man jumped down with initial velocity 10 meter per second. So, dia dah ada initial velocity. And then, the value should be negative sebab dia turun ke bawah. The height of the building is 72 meter. Calculate the time taken for him to reach the ground. So, S is also negative sebab dia berada di bawah reference level. So, when we say reference level, it's where the man started. Okay, di mana titik mula dia. So it's negative 72. So we use the suitable formula to find T. Okay, number 3, a ball is thrown vertically upwards with initial velocity 20 meter per second. What is the highest point of the ball? So highest point is asking about the maximum height. Okay, so this is the diagram showing the situation, okay, where the ball is being thrown upwards with the initial velocity 20 meter per second because it's going upwards, so it's positive. And then what is the highest point? So you need to find the distance S of the ball at the highest point. Okay, but we know that for highest point V is equal to 0 because the ball is as if it has stopped at the highest point. Okay, seperti bila kita baling atas, dia macam berhenti seketika sebelum dia turun kan. So bila dia berhenti, the velocity is equals to 0. So we have U, V, and we know G, 9.1. And then we need to find S. So which formula is the most suitable? This one. Okay, you just substitute and you will get positive 20.39 meter. Positive because the displacement or the S is above the reference line. Okay, number 5, a ball is thrown vertically upward with initial velocity. Okay, situasi dia sama, going up, so the initial velocity is positive. What is the maximum height for the ball? Okay, so maximum height V equals to 0. And then U is positive. Then you can find the highest point. B, how long does the ball take to reach a point 5 meter above its release point? Berapa masa yang diambil for the ball to reach 5 meter from the release point, mana itu adalah reference line. Okay, so S is going upwards, so S kita adalah positive, U positive 12, and then we have G because gravitation. Then you need to find T. Okay, jadi formula yang paling sesuai is S equals to UT minus half GT squared. S adalah 5, U is 12, G 9.81, and you can find T. Okay, here, why do you have two answers for this question? Okay, so just now for A, you have calculated that the maximum height is 7.34, which is somewhere around here. Okay, so this ball, bila dia lalu dekat 5 meter, it will arrive at the highest point, lepas tu dia akan turun balik. So, 2 kali dia akan lalu pada 5 meter ni. 2 kali dia akan lalu. So, the first time is when T equals to 0.53 second. Lepas tu dia patah balik 1.91 second. So, dia ada 2 masa dia lalu dekat 5 meter. Alright, number 6, a ball is thrown from the top of a building is given an initial velocity 10 meter per second. Okay, dia dibaling daripada atas bangunan 10 meter positive straight upwards. Okay, the building is 30 meter high and the ball just misses the edge of the roof on its way down. Okay, maksudnya bola ni kita dah baling dia naik atas, lepas tu kita terlepas daripada bangunan tu, dia turun ke bawah lagi. And then the first question is to find the maximum height of the stone from point A. Okay, again, the keyword is maximum height. During maximum height, Vy or V is equals to 0. Okay, so we already have one parameter. We are given the value of U, which is 10 meter per second, and we know G is equals to 9.81. You need to find S. Okay, so the most suitable formula is V squared equals to U squared minus 2GS. So you will get the maximum height. Next, the time taken from point A to point C. Okay, so focus on point A to point C. So what is the displacement? Okay, so A is starting at 0. And then let's say the highest is S max. Okay, so this ball travel positive S max. And then going down with negative S max. So what is the total S travel during the motion from A to C? So positive S max minus S max. So we get 0. So the information that we already know is that S is equals to 0, U is equals to positive 10 meter per second, G is 9.81, and then we need to find T. So the most suitable formula is S equals to UT minus half GT squared. Here, after you substitute the value, you will get quadratic equation. So you just have to solve it. Okay, and then you will get T equals to 2.04 second. And another T is actually equals to 0. So the most suitable answer for this situation, sebab motion dia from A to C is 2.04 second. Next, C is the time taken from point A to D. Okay, so kita kena pasti dulu the reference line from where A started. So di sini S sama dengan kosong. And then the distance between A and D. So this is the initial point. This is the final point. So the distance between them is negative 30 meter because 30 meter is the height of the building. Okay, so using the same formula as before, it's just that we have new value for displacement. Substitute with the negative sign because it's going down, so you will get the answer. Okay, so the velocity of the stone when it reaches point D. So point D is the lowest point on the ground. U is 10, G is 9.1, T is the total time travel from A to D. So you will get negative because it's going downwards. Okay, number 7, a student drops a stone from a second floor window 15 meters above the ground. How long does it take for the stone to reach the ground? Okay, so the punya keyword here is drops. So when an object is being dropped, the initial velocity is equals to 0. Okay, tiada hal laju pada initial point. Okay, so from our equation, S equals to UT minus half GT squared. So this one can be cancelled out. So our equation is only this one. So just substitute the value, which is the height of the window, negative 15, and then you will get T 1.75 seconds. Calculate the velocity before it hits the ground. You need to find V, U is 0, A is the negative 9.1, and T is a 1.75. Then you get the answer. Okay, so number 8. The most asked questions. Ramai yang keliru dekat soalan ni. So basically, this is a rocket situation. This rocket is launched vertically upwards from the ground with initial velocity 35 meter per second. It is accelerating at 5 meter per second squared. The engine suddenly broke down at height h equals to 20 kilometer from the ground. Okay, so for this question, you are lucky enough because there is a diagram for you. Kalau tak ada diagram, you need to sketch on your own. Okay, so h is given 20 kilometer, okay, until this point. And then it's traveling with u is equals to 35 meter per second. It should be positive because it's going upwards. And then this rocket is actually accelerating. Dia ada pecutan 5 meter per second. So dia naik atas dengan pecutan. And then the engine suddenly broke down. Okay, bila engine dia mati, that is when kita starts using gravitational acceleration. So there are two phases over here. The first one apabila dia pecut dengan menggunakan engine dia. So that will be A equals to 5 meter per second squared. When the engine suddenly broke down, okay, dekat bahagian sini, lebihan yang ini, yang biru ni, going down is all affected by gravitational acceleration G. Okay, so this speed kita pakai A, this speed kita pakai G. Okay, calculate the speed of rocket at height 20 km. This is where the rocket broke down. Okay, so we need to find V. U is given A now because it's still using its own engine, its own power to accelerate. So kita pakai A equals to 5, then we'll get the answer. Okay, then the second question is to find the maximum height achieved by the rocket. Okay, tadi from the ground to where the rocket broke down adalah 20 km. So just now we have calculated at this point, V dia equals to 448.6 meter per second. Okay, so pada ketika itu kelajuan dia tu masih tinggi. Jadi this rocket, dia akan still moving, dia akan terlajak naik lagi sampailah dia reach maximum height, dia tak boleh naik lagi dah. Okay, sebab enjin dia dah mati. When the rocket reaches the maximum height, V is equals to 0. Okay, so now kita dah ada 20 km. You just need to find another distance travel at this point daripada dia broke down sampai maximum height. And then, so the total is kita tambahlah 20 tambah dengan X. Okay, so berapa dia punya total distance? So to get this point, this height over here, we can use this formula where V is 0 because maximum height. U adalah U ketika dia mula broke down, bukan from the ground. Start bila dia broke down. Okay, sebab di sinilah kita start using G. Okay, so we get 10.26 km. Then you need to total up H and S, you get 30.26 km. Okay, ni dia label sebagai S. Saya label pada gambar X. Sama saja. Okay, then 3 is to find the time of flight of the rocket. Time of flight ni maksudnya masa dia berada di udara. Okay, so just now we have seen bahagian kuning adalah when we use acceleration equals to 5. Okay, sama dengan 5 meter per second squared. The blue color is when G equals to 9.1 meter per second squared. Okay, so to find the time of flight, you need to find T1, okay, when the rocket is under the influence of acceleration equals to 5, and then T2, when the rocket is under the influence of gravitational acceleration. Then you total up T2 and T1, you will get the time of flight. Okay, so for the phase yang warna kuning ni, U kita bermula dengan 35 meter per second, and then the rocket broke down at V equals to 448.6 meter per second, and then A is equals to 5 meter per second squared. Then you can find T1. Okay, so this is T1. So for the second phase is when U dia bermula dengan 448. Okay, untuk perjalanan kedua di bawah pengaruh gravitational acceleration, U kita adalah 448.6 meter per second. Tadi dia adalah akhir untuk fasa pertama. Tapi untuk fasa kedua, dia jadi initial. Okay, how about S? Apa nilai S kita? Okay, so S adalah sasaran. You need to focus on the initial point. So, initial point di sini. And then the final point. So, what is the distance between the initial and the final point? Jarak dia adalah sebanyak H equals to 20 km. So, this is our S. Awak tak perlu ambil tahu bahagian atas ni. Okay, sebab sasaran, we just need to focus initial to final straight line. So, S is equals to negative 20 km. Okay, don't forget kilo is equals to negative 20 times 10 to the power 3 meter. Mesti unit dia sama. This one in meter, this one should also be in meter. So, then you can cancel them correctly. Then, substitute the value into the formula. Okay, then you can find T. Okay, here you will get quadratic equation. So, ada kuasa 2. Here you can directly insert the value into your calculator, then you will get two answers. One is positive 124.17 second, another one is negative 32.8. Okay, usually the right answer is positive lah, negative tu you can ignore. So that we have got T1 and T2, the time of flight is the summation of these two. Tambah saja, that is the time of flight.